Hello. Can you guys hear me now? There we are. Hello. I see some faces that I've seen before already. That's really good. That means that we have similar interests, I guess. I'm wondering how many people are here because they think we're going to be able to hit the compile button on a Word document, because that would be pretty neat. But that's not exactly what's going to happen. My name is David Starr, and I work with Scrum.org, specifically looking at technologies, how they impact Scrum and how they are impacted by Scrum and iterative incremental development, agile methodologies and practices, et cetera, et cetera, et cetera. That band that was playing right before we started, by the way, that's a 25-year-old recording from a new wave band when I was a kid in Texas. So they let me play that on podcasts and stuff. It's pretty cool. Okay, there is my Twitter handle, so I'm sniper bait for you, and here we go. This is how a lot of us are probably still developing software. Is this happening for anybody here? There are some people laughing, like, oh, and then you cry. Yeah, I know. Only you're not crying too badly because you're the one doing it to them, aren't you? If you're here, odds are you're the developer. And it's good to be the king because you can just keep delaying. What we do is we assert that we've got to add a little more time to our development schedule in order to ensure quality. And in order to do that, we cut down on the amount of time we use to ensure quality. That's how it went for a long, long time. Now we do something a little bit different. We do the same thing but quicker, right? We at Scrum.org call this Scrummerfall. This is a very typical pattern for how people address the problem of what do we do with testers before software exists. And it has everything to do with our base assumption that the job of people who have a comma tester or QA specialist at the end of their title, the assumption is that they are there to verify work. And today we're going to talk about flipping that on its head completely and looking at it in a very different way. And so instead of pushing down QA to the last day of a 5-day sprint, we'll try something different. Now, if you listen to the software consultant world out there, including me, because I've said this a few times, here's what we tell you to do, right? We tell you to do a little bit of everything all at once. And, of course, you need rainbows and fairy dust in order to pull that off. That's the idea that I'm going to share on one team, maybe next to each other in a team room, the responsibility of delivering a feature between a tester and a developer. This can actually be done, but we don't really talk a lot about what that really means. In fact, I got for a while really good at answering when someone would ask me how that's done and say, I don't know, you figure it out. There's the consultant answer. So I don't like that anymore. We'll look at a different way. Maybe like this. Maybe what we can do is ask those people who are really good at understanding what our software should do, because that's what they've been doing. They're called testers, or they're called business analysts. And those two career trajectories are coming together in our industry, there's no question. Maybe what we could ask them to do is join our team. And so they sit on our team, maybe right next to us, as we described a few moments ago, but instead of waiting until the developer hands them software and says, how does that look? Instead, they say, here's how the software should behave. And the job of the software developer becomes to make that true. How do we do that? Well, we create a requirement, and in many cases, this is done far before any development cycle. So I'm going to use, I'm sure people in here get Scrum, you know what the iterative incremental practices mean, so I'll talk about it in that way. These requirements can exist long before we actually get into a sprint, no problem. And the idea is for each requirement that we have to produce, of course, working software. Now, in order to do that, we create this thing called acceptance criteria along the way. And usually the way this goes in a Scrum team is that there will be a product backlog item. We'll walk into a backlog grooming meeting or into a sprint planning meeting, something like this, and the product owner says, this is what I want. And the developer says, yeah, but what about this condition? Developers are really good at this. Yeah, but what about? Yeah, but what about this? The answer to each of those questions we can record as what we'll call today an acceptance criteria or a scenario. For each one of these, once they exist, and maybe we've written them into Team Foundation server work items, maybe we've written them into Word, maybe we've written them into Excel. I don't know where we keep our requirements. It varies. Once they exist, however, what we can do is take for each one a moment to create a failing test that reads like that. Okay, this is starting to become interesting in the world of software development. I think this idea of creating a failing requirement as a test is really on the verge of being an important thing in our industry. This could change things. This could change the way we work on software. This could change the way we talk about it. Okay, so we'll look at the structures of that. We create a failing test, and this is not the kind of test that you may think of if you've been hearing test-driven development, TDD. Good grief. Stop it. Wow. We'll just wait. It's great. Holy cow. What do you guys think that is? My God. Okay. These are not the kind of tests. Yeah, let's do that. Let's give it to them. Hey, it worked. Thank you, guys. I'll pretend that was for me. All right. Creating a failing test in this case does not mean the same thing it does in a test-driven development scenario where a developer is defining software just a little bit ahead of where that software is being implemented. That's more of a jig, if you want to think about it that way. If you're familiar with how to build boats, for example, we can think about our unit test harness as a jig that gets created just a little bit ahead of our system under test. That's not the case here. This is a requirement that fails probably in a different assembly. As a developer, though, I'm then going to try and meet that requirement. If I'm a good little developer, I'll probably use test-driven development. It's a level down, though, from the requirement itself. And finally, if I do all of this well, I'll be able to make the test pass. This is that failing thing, that requirement. And now I get to think about this as a requirement that it has been met. And I do that over and over and over. That's the whole idea. Doesn't seem very complicated. And it isn't really. It's a very simple idea. But like so many simple ideas, like Scrum maybe, it can be extremely hard to achieve this. I like to think about things I can't compile, requirements that I can't compile, as desirements. Because nobody actually requires the software to do anything. That's not true until we have a failing test. A failing test actually is a requirement. Otherwise, you're just wishing. I sure wish the software had this feature. And even if I write it down in Word, you're still wishing. You're just wishing really hard. I'm sure that everyone here has seen this before. I'm not going to belabor it, but this happens to provide for us a grammar that we can use to tackle this problem of executable specification. How do we compile a requirement? Now, the as a I want so that bit. As a developer, I want a Visual Studio IDE to have a little color so that I can enjoy it all day. Whatever. If you see these sentences written out, odds are they don't mean a lot to you as a developer. They mean a lot more. I think they're more meaningful for product owners, for people who are business analysts. They pass those sentences around. It's meaningful for them. However, the scenario pieces, these acceptance criteria that say things like given, when, then, this is more interesting. The reason it's more interesting is because we can do things like this. I can look at this unit test method, which is very simple. It's using MS Test as a unit testing framework. And it's a shopping cart. It's about the simplest example you can get. And what we see happening in this test is what happens in every test that's ever been created for software. There's a 1, 2, 3 thing going on here. Number one, we're going to take that system, spool it up in some way. That is, we're going to get it into a specific context. That may be instantiating it. It may be setting a particular state within that system that we're about to test, that system under test. In this case, a shopping cart. Then, step 2, we touch it, we poke it, we invoke some operation, we change its state in some way, or we give it a command to change its state. Once that happens, finally, the third thing we do is check to see what happened as a result of poking it, right? That's it. It's true if you're doing manual tests, it's true if you're doing test-driven development with unit tests as a developer, and it's true if you're doing really large regression suites of test cases. This is what a test looks like, 1, 2, 3, every time. We can take advantage of that in this way, overlaying the structure and taxonomy, that language, on top of the way we've been writing unit tests. Let's go look at how that might actually work. There have been a lot of attempts at this in the last few years. I'm going to start looking at this example. This is the way we try to tackle this problem for quite a while. What I have here is a very simple base class. It should have probably been made abstract. But it's not, whatever. Got these virtual methods. Note that in the constructor, it's actually doing some work. It's doing that arrange and act bit. And remember, we called it given when then a few moments ago, but it doesn't really matter, does it? Arrange, act, assert, given when then, 1, 2, 3, who cares? It's a 1, 2, 3 thing that's happening. But what we recognize is that wouldn't it be great if my users, my stakeholders, my mom, could read the requirements? Wouldn't that be great? And they could read the requirements as a test report. So here was our first attempt at that. Go in here and we've got a baseline sprint goal. So this is kind of what we started doing. We tried to name things better. Here, let me bump that up a bit. We tried to name things better. When I have a new sprint goal, then the sprint goal serializes properly. Oh, wait, sprint goal. I'll get back to that. So here we're setting up our system under test. Here we invoke some operation, and here we're asserting against it. The only thing that would be nice is if we had a separation of concern between these activities. So that's what we use our base class for. We actually inherit from that base class. See, here's my new test. And here I do an arrange where I new up that sprint goal. And then I act, I serialize it. And then I do an assertion here. I check the output of that particular invocation or operation. Now, before we get too much further, I got a little ahead of myself there, and I apologize for that. Let me show you the app we're playing with. I think coming up with sprint goals is hard, so I wrote an app for it. There we go. That's the kind of thing most of us say anyway. How about something equally ambiguous? And we can just go ahead and make tons of these. If that's not helpful for you, maybe you'd like to estimate something. All right. So we're looking at our little sprint goal generator code. That's what we're playing with at the moment. Now, what's interesting about this code is, firstly, the separation now of concerns. But this is a developer thing. Because if we look at what the test looks like when we run, let's go ahead and run this. What we've got here, and I'm using the ReSharper test runner. I hope Mr. Provost is not in the room. The ReSharper test runner gives me hierarchy. And we started doing techniques like this, or using techniques like this, to take advantage of the fact that pretty much every test runner in the world does show hierarchy. And so we started treating those hierarchies as sentence clauses. And so here is one. When I have a new sprint goal, then the sprint goal serializes properly. That's a sentence. I can read it. I can pass it off to perhaps my mom, whatever the case may be. In fact, there was a very real project that I was a part of for a while, in which we developed a point-of-sale system and also some online shopping stuff, e-commerce system for a veterinary supply company. And this lady who was our customer, her name was Michelle. She lived in a smaller town than I do, and I live in a small town. I live in Idaho, which you've never heard of, and that's probably best. And she knew nothing about software. That's why she hired us. No problem. So I would be on the phone with her every day. And I would say things to her like, what would you like to happen here? And she would explain the answer to that. And I would put it back to her, restate it back to her like this. So what I heard you say, Michelle, was that given this page is on the screen and you've entered some data into here, when you click this button, then that happens. She'd say, yeah, that sounds about right. Great. So I'd write it down as a form of specification, and then I'd come over here and whip it out in my little AAA class. And I thought, everybody's talking about the given, when, then thing. Maybe that looks a little different. So what I realized, let's see, I'm just going to let that collapse. There we go. What I realized over time is that this is the developer inserting him or herself into language. Michelle didn't know anything about a range act assert. I thought then she must know something about given, when, then. So I created a different little structure, as many of us did. This was certainly not something that I came up with. And we just changed the language inside this little class. Now we can simply inherit from this one, and maybe Michelle will be able to read this one even better, right? So I come up here, and I'll just do this horrifically bad thing. I just cut and pasted code. I feel a little dirty right now. It's pretty pasty out there. All right, and so instead of saying arrange, we say given. And instead of saying act, we say when, right? It's just a vocabulary thing. So I'll run that. What do you think we get? Well, according to Michelle, we get exactly the same thing. There we go. When I have a new sprint goal, then the sprint goal serializes properly. When I have a new sprint goal, then the sprint goal serializes properly. So we've just proven that it has absolutely no impact on the customer's understanding of our requirement, which one of these taxonomies we want to play with as developers. Developers have had purse fights over this for years, and it doesn't matter. And we just proved that because the real goal here is to be able to have Michelle read those requirements in a report of some kind, or maybe have someone like Michelle specify these tests, create these tests ahead of time. Now, do you think that it might make sense to have a QA person on your team go in and create tests like this ahead of time? Sometimes, maybe, but odds are they're not going to be that technical. They're not going to want to live in Visual Studio. Enter Gherkin, which I learned is not just a pickle. Also, I have one of these sweet little touchscreen tablet computers because I knew Windows 8 was coming out. I thought, man, I got to have one of these. It's going to be great. I'm going to have Windows 8, and so I need a touchscreen. So I bought the touchscreen. I've had it for probably 9 months, and I've been playing with it and using the touch all the time, and the only thing I've really done with it is draw that pickle. That's pretty much the extra $200 that I spent right there, is that pickle. So I hope you like the pickle. Gherkin turns out to be a domain-specific language. It's a DSL. And what all that means is that it is a language that a computer understands, but that is meant for a specific domain. Duh, domain-specific. And in this case, the domain-specific, or the domain of Gherkin is testing. That's the idea. Or requirements, however you want to look at it. We have to be able to compile and run this thing, so machines have to be able to understand Gherkin, and they do. So much so that when we're done creating a test harness with Gherkin, it can easily serve as the requirement, or sorry, the documentation of functionality for that system. Not for Michelle, but for the next developer that comes along, absolutely. So years ago, who remembers when they first came out with Patterns and Practices came out with the, I can't believe I'm doing this. The Composite Application Framework for Silverlight and WPF. You guys know it. Prism, thank you. God, I can't believe I just did that. Thank goodness you're here. Prism. When they first came out with Prism, the guy that made it, his name's Glenn Block, and that thing shipped, and I called him up and I said, hey man, this seems really cool. It's great. How's it work? And he said, well, Dave, duh, you're supposed to be this agile hippie. Go read the tests. I'm like, all right, I'll go read the tests. And he tried really hard to make his tests read like this. If you go pull the source for the 1.0 version of Prism, a lot of the tests in there read like that because Glenn was really trying. And I still had to step through that thing with a debugger, to be honest. Well, Gherkin says we can actually compile this language that we've been talking about all along. We're not really changing any of the structure and syntax of it. The only difference now is that we're going to consider each one of these small things under scenario to be a step. What's a step? It's a line of language that can map to a method in our code. This will all come together in a minute, I promise. And it turns out the last time I looked at Gherkin, which you can go do online, it's an open source project, you can go out there and see that there are 47 different languages supported today, which is far more interesting here than it was in Florida a few weeks ago, where no one cares what you guys think. There's America for you. Sorry. Okay. Gherkin looks like this. Let's pop back over to Visual Studio. We're done with this project, so I'm actually just going to go ahead and drop it so it won't be in our test runner. There's a tool called SpecFlow. SpecFlow is patterned after a tool that the Ruby community came up with called Cucumber. Both SpecFlow and Cucumber use Gherkin as their primary model, or DSL, of requirements language. See this, by the way, this little GUID banking node? This is my future feature, which is going to allow you to store GUIDs in a database when you're not using them and then take them out again so you don't feel bad about killing them. Because I feel guilty about that. Okay, sprint goals. I want to add a requirement to my Visual Studio project. So I'm going to add a SpecFlow feature file, and I'll call it sprint goal requirement, whatever the case may be. Good enough. Now this is going to churn for just a moment. Now I will tell you too that everything I'm going to do in the next 20 minutes is pretty risky because I've actually been on the phone with the guys who make this stuff to get it to run in Visual Studio 2012. Within the last week, we've been trying to make all these things mesh up, and they are. They're doing good. Very well, I should say. Okay, now when it comes in, a new feature, this is sort of like dropping in a new web form or a new Windows form. It's a form, and I can fill it out. And it has language associated with it. I can come in here and say, for example, let's see, let me do it this way. There, it's got some IntelliSense associated with it. So they've invested a little bit into this editor, which is pretty nifty. What I'm going to do, though, is I'm going to go ahead and put in a requirement from Team Foundation Server. Let's see, where is TFS? Here we've got to generate a sprint goal requirement. And this is how we're used to seeing it. Oh man, you guys in the back promised me that the internet would be up. And it's not. Awesome. Oh, there it is. Okay, good. So what do we have? We have a title. It's called Generate a Sprint Goal. There it is right there. And we've got this user story thing. Now that user story syntax used to be default in the Scrum template in Team Foundation Server in 2.0. That's no longer the case. Because lots of things can be product backlog items. Just saying. Over here under acceptance criteria, we've actually outlined these as scenarios according to the Gherkin structure that we've talked about already. So what we can do then is take this sentence, or this requirement, let's just put it in here. So remember that had at the top something called feature. We have to give it a name. This is sort of like a handle so that we can walk down the hall and talk to each other about that feature without reading out this big long sentence. We'll say sprint goal instantiation or something. I don't know, making it up. Now the next part of that is that we want to have the acceptance criteria, so we'll take that, drop it in. There's our acceptance criteria. Let me just format this up a wee bit. Okay, there's our form or our requirement, and I just hit save. Did you see what happened when I hit save? Over here, it created a code behind file. So there's a code behind file for this, just like there's a code behind file for your ASPX file or your XAML file. If we look inside here, tell you what, I'm going to start up my zoomer so we can look more closely. If we look inside here, we see something interesting. A few things. One, let's drill down. Let me find a attribute. There we go. See that? That is sort of the sentence that we were looking at in that feature file a moment ago. In fact, that's exactly it. And if we come down here, we look at these sentences, it turns out they are expressed as strings in here. Now, what's going on? Well, what's going to happen when we run this is that SpecFlow will look and see if there are any methods that will match up according to an attribute such that these sentences are there in scope. Let's go ahead and run it. I'll run it over here under Unit Test Tool. Actually, I'm going to do it with the ReSharper runner again. Everybody, you ever notice that RUN is the ReSharper run? That's awesome. Whoever made that. Okay, we'll leave this alone for now. We'll come back to it. Here is where we are. And if we look at this sprint goal test, it resolves right here inside this file. So the tests are actually here. And I would expect this guy, hello, he's still running? I think I'm locked up. There we go. That took a bit. All right, so here is the output of that test. It failed. This test failed. However, what it did is it told me, this is how the designers of SpecFlow decided to implement this. It said, look, this is the code that you need to implement to make your test pass. Huh. We can actually just pull this out of here. There's the code. And we don't want to be working in that really bad-looking code behind file. We're going to come over here and create, let's do add new item, something called a step definition file, which quite frankly is not much more than a class. And inside this file, you can see that they've stubbed some things out for us, part of the item template. Thanks. But I think we're okay without that. There we go. That's what was in the runner. And so the runner told us the code that we needed to implement. So now I'll go ahead and run this again. This time, we should still fail because we haven't implemented anything. It's running. The fact that it turns green while it's running is disconcerting, I think. Gives me a false impression that I'm okay. There we go. Oh, no, it's still running. Goodness. I don't know what's going on that this has taken so darn long. Every bit of this is early access, including ReSharper, including the runner, including Visual Studio, every bit of it. So don't feel too bad about performance. Okay, so now let's look at what we have. And let's think about the workflow state we're in right now. Perhaps, just perhaps, a tester or a business analyst or someone like that was taught how to work inside Visual Studio to create these feature files. Check them into the repository. Developer pulls them out, runs them. Hey, look, you don't have any implementation. Create my step definition file. And then when I do that, I can see that each one of these steps is reported back through my runner. Given I don't like the first sprint goal, when I click the Again button, then I get a new one. And note that these things are not yet passing. We can make them pass one step at a time, and we'll do exactly that. We'd come in and we'd make the given pass, and then the when, and then the then. I won't make you watch me type all that, so there's the implementation. See how fast I can type? Now let's run that again. To be very clear, these are integration tests. They are meant to be integration tests. These are not unit tests. These are going all the way down in the stack and all the way back out again. So if you've got a database under there, probably touching that database. And we passed. So now we have two specifications that we're passing. With every unit testing framework that I'm aware of, and also all of these behavior-driven, acceptance test-driven types of things like SpecFlow, you can generate a report of some kind that I can then share after my automated build runs. I can put these reports out during my build automation. The point is not to go too deeply into the features of any one of these, but for you to simply think about how you might apply the idea of the executable spec to your world. Now, so far, what we've seen requires Visual Studio. It just does. It's not necessarily a bad thing, but in a lot of places, that would be somewhat intimidating. These guys at SpecFlow, and I don't mean for this to turn into a SpecFlow fanboy party at all. However, these guys have created a new tool that's only recently come out. Lost my context. There I am. Called SpecLog. I'm going to open up a SpecLog repository here. It's telling me it's already open. I'm not loving Windows right now. There we are. Okay, now what I'm looking at is this SpecLog tool. These guys that made SpecFlow made it available and open to you for free. This thing is kind of that next step that you would expect. What I really wish is that the right-hand side of that work item type definition in Team Foundation Server, I could type in there and it would save as code. What if that were a code editor? Well, what these guys have done is created something kind of like that. And what we're not going to be able to see is the integration with Team Foundation Server that it does have, because they do currently integrate with 2010, not 2012. So we're not going to play too much with the integration. What I can, however, do is open this local repository of requirements. This is a repository of requirements for a bookshop in this case. And what's really nifty is I can zoom out. And has anybody been to a session this week already on storyboards or storyboard mapping? You have. Okay, great. A couple of people did go to that. This should look like a storyboard map, the one you learned about. Now, what's clever is that as I zoom in on these, right now they're IDs, then we start to be able to read the requirement a little bit. Pretty slick. So these are all actually backed by a Gherkin expression of a requirement. This is pretty much exactly what I wish I could do in Team Foundation Server, right? So let's go ahead and open one. I want to make sure I pull the right one here. Well, that didn't come up. I thought maybe it was taking a while to paint. EG18. Looking for a requirement EG18. It's in here somewhere. Have you noticed that these guys took some interesting UI choices? I've actually had a hard time working with this. Okay, what they've done here is they've got this requirement. Think about this as a work item in Team Foundation Server. They've attached an image. This is their UI mock-up. I find, by the way, that this makes an excellent way to have the conversation with Michelle. Because what I'm able to do is point at things and say, for example, what should happen when I put something in here? And she'll say, given there's some text in there, when I click the search button, then this should be the result. And that works really, really well. So a picture along with these 1, 2, 3 structures works quite well in my experience. And here they are. Here are the ones that have been created in this particular set of requirements. So this is a feature definition. And it has several scenarios associated with it. It's got a drawing associated with it. And the ultimate goal of the tooling here is that we'd like to see it compile. One thing we can do is we can link it to a Gherkin file. So this is that .feature file. See there? The idea is that we'll be able to link this to a feature file, basically compile it, pops out into that feature file, which is part of my version-controlled artifact as part of my project. Then we go in and we implement the step definitions. Now, I'll admit that I'm a little confused by this UI. But the spirit of this tool is just thrilling. Where this is going is a world where people can express what they want clearly in English or in whatever language is comfortable for them. And that becomes a requirement that fails as a test. The job of developers then suddenly changes a bit and turns into one of making test pass or implementing requirements. It's pretty slick. I'm going to flip back over and we'll go here. Now, as I mentioned earlier, I work a lot with Scrum teams. One of the things that I do is I help the two guys that invented Scrum, Ken Schwaber and Jess Sutherland. They have this document called the Scrum Guide. It's the rules of Scrum. You can go get it at Scrum.org. And it's just like you would see rules inside of a Monopoly box lid. One of the things we've done recently, within the last several months, is we've removed certain aspects of Scrum that would prevent what we're going to talk about here. So Scrum's changed a little bit to accommodate this idea that what if what we did when we started a sprint was we simply had a set of failing tests, and the job of the business analysts and the QA people on our team was to go and begin creating more and more of these, more and more specifics of the requirements, so that they're building those requirements just a little bit ahead of the developers throughout the sprint. What would that look like? And we think it looks like this. In fact, there are teams out there doing this today successfully. Once they've done that, usually there's a point about 2/3 of the way through the sprint where the software, or the development team, I should say, the development team, people on there have pretty much specified all the features they need. Now they can go start focusing on other types of quality assurance measures, ILITs, right? We can move our attention to performance testing and other things that do still need to occur within the sprint. But the developers then have to catch up with those failing tests, and that becomes the way we monitor progress through the sprint. You don't have to do task decomposition to do Scrum. All you need is a plan and a way to see how much work remains in the sprint. Could we count how much work remains simply by asking how many tests have not yet passed? Sure. That's a perfectly valid sprint backlog. Okay, now because I'm who I am, I'm going to make some gross generalizations, because that's fun. Firstly, you're not going to be able to do any of these things unless you have an architecture that will support it. Luckily for you, an architecture that will support it is a good one. I didn't say that the other way around. You don't have to design for testability, but if you're designing well, you'll be testable. How's that? Okay. We can test right here at the view level. In fact, I had a talk earlier today wherein we played with some technologies that do that. By the way, if you were the gentleman in that room, the demo works now. I fixed it. Sorry. Misspelling. Okay. That was a bad moment. But these tests are brittle, and we know that. If we do record playback at the view level, it's particularly brittle. There are some other technologies that let us, maybe even coupled with the tools we've seen, do stepwise testing at the skin. Things like Watton. Now, in terms of model view separation, if we are separating our models and views properly and well, then odds are we don't need much testing around the models. These should be really dumb objects. DTOs, or data transfer objects, is what we hope to see here. Yes, in the MVC framework, we have some very complex model binding and model builder type features, and that may need testing. But in general, models are pretty dumb. We hope they are. They look like it. Nobody caught that. Okay. Controller and presenters, or view models in the case of MVVM. This is where we probably are going to tap in with these specs, and that's exactly what we did in those specs that we looked at before. The spec flow given clause usually instantiates a presenter. At least that's how I do it. You could instantiate a web browser and then in the when clause go right against the view. What I prefer is to instantiate a controller, presenter, what have you. In that given clause, that's my context. The when is the invocation of some operation, hidden action, right? And then the assertions are testing the view that's returned out of that, or the model that the view has. It's very common. So we see a lot of testing at the controller presenter level, and we see a lot of testing here. This is good stuff. This is not the stuff, however, of where we drill in with requirements. Right? There's no way Michelle is going to be able to have a conversation with me about commands and factories and services, nor should she, or entities, what have you. But we as developers, we want to test here too. And we want our test to be readable to the next developer that comes down the line, and it turns out this structure that we've been looking at works just fine, works very well at that level in our application architecture. Because we're still just doing 1, 2, 3. So can I write given, for example, given that I have a user repository, when I add a user to the repository, then it is persisted in the database. That's a check, an assertion. And here's another assertion, that I can retrieve it from that repository. I don't know, that's probably too many ideas in one requirement, but it's a valid requirement at a technology level. Probably we're doing mostly unit testing here. Still can use unit tests with this structure, no problem. If you're having to test at your data access layer, pick another one. And it turns out that some people believe this. In fact, I'm really sad because a friend of mine who's sitting in the back row just a few minutes ago and had to leave will tell you all about how there are database unit testing tools out there in the world, and there are. And I've never met anybody that's used one, but they're cool. They're really cool, and they demo quite well. So there are tools out there for doing all of these things, all these practices that we've been talking about, even against the data layer. And it's probably worth your time to learn a bit more about those. Now, I'm going to pop over here to Visual Studio once again. And now I'm going to go down inside yet another unit testing library. Now notice that I've got things split out into these different assemblies. It's probably best, by the way, to have an assembly or set of assemblies that is just integration tests that are defined by this process of executable specification. And then the developers work over here in a completely separate assembly doing unit tests. That will keep your worlds nice and clean. There's another tool that I find this one particularly interesting. It's called Subspec. Subspec is the first tool that I have found that recognizes the fact that the developer language structure doesn't matter, like we asserted for the first half of this discussion. And the way they've done that is they've implemented a set of extension methods against strings. And so I can say context, and if this syntax looks funky to you, it's a little funky. There we go. Now I've got a helper method in there for me already so that I don't have to guess. This is for your benefit, believe me. Okay, what we've done here is we've simply extended a string. Now I can make that string say whatever the heck I want it to say. It happens to read the same way as a Gherkin statement, but there's nothing about it that would require me to only use that language. So I'm going to go ahead and implement the next step of this. Note that this is just a string. And they're using the language of context spec. That's what developers care about. The developers care not about the strings, but about those extension method languages. So given a new goal, here's my context. When it's serialized with delimiters, it's the same test. Then what? Then we can use there we go. Then we can use an assertion clause. And wouldn't it be great if I could type better? There we are. Again, we're going to throw in that anonymous method. We just need to implement our assertion. Just going to grab it. There we go. Okay, so this becomes a test. We'll run it. The name of it is custom delimiter is correct. Let's rescope. There are too many runners going. Let's see, custom delimiter is correct. Where is this guy? There we are. Run unit test. Now, this particular test uses, lovely, of course. This particular test uses XUnit as the underlying unit test framework. Subspec does that. It chooses to live on top of XUnit. It works pretty well. XUnit, by the way, is an incredibly extensible unit testing framework. If you're not using it, start. If you're using MS Test, quit it. If you're using NUnit, know this. The guy that originally did the port of NUnit, his name's Jim. He now works at Microsoft. And he and another guy, Brad Wilson, Jim Newkirk and Brad Wilson, are the guys behind XUnit. Jim's statement about XUnit as a unit testing framework is, this is how unit testing should be as I learned when I created NUnit. So what's cool about that is that we can simply add, which is what Subspec does, some other inheritance classes into our project. This is not unlike that AAA stuff that we saw earlier that was taking advantage of inheritance. So anyway, XUnit, if you haven't noticed, is being embraced in Visual Studio and in the testing tools that we're seeing out there. You might think that that's important. So pay attention to XUnit. Okie doke. Let's see what's going on here. Do I have a compile? I do have a build. So let's look at what my failure was. Failure was, of course, the null reference exception. Lovely. Even better. There we go. Okay, so we've got our test passing. These tests inside Subspec are, to me, the most promising way forward. Now, I don't think that any of these tools have it right. Particularly, given that they have to live on top of the language and live with the language that they're in. I mean, C#'s a hard thing to make readable to Michelle, right? But we're working on it. All of these tools try to bridge that gap, and this one does it without causing the sentence to read in some way that is specific. Let's see. I was hoping it would show me, but it won't. Now, the next level down that we talked about a few moments ago, we said that it's perfectly valid to use this structure inside of our architecture, not just at the high levels where we've specified requirements ahead of time, but also down inside of our system as we do TDD. That's exactly how these tests at this level were created. These are tests for little command objects, and they're running and working just fine. You know how we all have pyramids in the software development world? You see them all the time, right? And this is a pyramid that exemplifies what you should do. Well, here's another one that tells you what you should do. You should have very few tests that talk to your GUI. We're going to have more tests at this feature or acceptance test level, right? Hopefully I want a dedicated assembly to just those feature tests. And finally, we'll have more and more and more unit tests. We have far more unit tests than we have integrated acceptance tests, I hope. Unit tests, I really wish we hadn't called them unit testing frameworks. We should have called it something else. Because we don't use those unit tests to validate what we do. We use it like this. You guys remember when we didn't have unit testing frameworks before Kent Beck? Remember that? It's been a while back. Maybe some of you don't. Well, what we used to do in Visual Studio 6 in 1998 was we would create two projects. You got your assembly, or at that time, whatever, your DLL project, and then you've got an executable. This is how you would build up your API. You'd write an executable alongside of it, and you'd exercise the thing as you go. You'd try to invoke the methods that you were making inside of your DLL using your exe, and you'd watch it on the command line, and once you got it to run, you'd say, nifty. And you'd delete that line of code out of your exe, and then you start working on the next method, and you'd make that one run, and then you delete it. All we're doing is exactly that with unit tests, only we're not throwing away the exe. It's the same thing. That is a design process. That is not a verification process. It's very important to understand that. And the way we use unit tests effectively in unit testing as developers is very much a design thing. If you don't grok that quite yet, spend some time playing with it. It'll come to you. This is essentially what we've said, as little as possible at the top. I would like to see one feature or automated acceptance test per requirement. So if you look, for example, at a Scrum backlog, product backlog, for each feature or product backlog item, have an acceptance test, an integrated acceptance test that fails and passes. And certainly with unit testing, one per module or so. Anybody feel like this? You probably don't, because you're here. Your boss, however, probably does. How many people in here have struggled or do today, by the way, with the question of my boss won't let me write unit tests? Yeah? So, how is that his decision? Or her decision? How is that not your decision? I've never understood that. Because if you're writing software like we all do, I assume you're probably already writing that exe, the one that we talked about a few minutes ago, that exercises your code as you create it. And if you're writing that thing, why don't you just not throw it away? And oh, by the way, use some attributes to bind up the methods, and let's do it with a unit testing framework. You don't have to ask permission to be a professional. What this does for us when we do this thing of building these regression harnesses is it puts a thin film around our system under test that lets us know when things change. I used to hear at Microsoft they had a term called shaking the jello, and whenever they're touching source code, the jello's shaking. And as it slows down and slows down because fewer people are touching it, as we come up to a release, we wait for the jello to stop, and then we ship it. And that's Windows 95, not 8, right? Okay, so this is the code, and when we touch it, we just want to know if that's going to have some effect on the other side of that code base. Right? You touch it, does it cause an effect on the other side that you can't see and you don't know about? So we put these tests, these feature definitions on top of our code so that we know when we touch our code and it makes something on the other side bubble out just a wee bit, that we get a failing test. And when that test fails, we get to go address it so we can fix it. This is how I sleep at night. If it weren't for this, there's no way I could sleep at night because I'd be constantly freaking out and worried that my production system was doing things I had no idea it was doing. Fortunately, we have a regression harness built exactly this way on our new website at scrum.org, not the one we have today, but one that's shipping soon, that does exactly this, and it lets me sleep. So here's what we've kind of gone through today. I really think, I like this word desirements, and we can turn those desirements into requirements. The technology is evolving. It's not there, not all the way, but we're getting there with it. I would strongly encourage you to look at some of these things that we played with today. If this is at all compelling to you, spec log, spec flow, and subspec in particular, I really enjoy these. There's another tool out there called StoryQ that uses a Fluent API to do a very similar thing, and you might also find that one interesting. Now, I know that we're a little early. We're, in fact, several minutes early here. I'm very surprised that we went as fast as we did. So I'm wondering, are there any questions about this? Is there anything that you'd like to discuss? Yes, sir. I'm sorry, I'm not quite hearing you, sir. Try again.
You said that talking to your customer, you only talk about specifications. You don't mention entity or value object, things like that.
Correct.
How do you combine it with distilling your domain name?
Okay. So the question was, I didn't mention when I told the story about talking to Michelle, I didn't mention to her the idea that inside my architecture there is a domain model. Right? There are domain objects like services, entities, repos, and stuff like that. What this gentleman is noting is that building out that domain language, when I talk to her and she says to me, shopping cart, that becomes a proper noun in our domain, and I probably have a shopping cart thing inside my domain. This thing that you're referencing is a technique from Domain-Driven Design and Greg Young. I don't want to marry or blur these lines together, but suffice to say that as I have the conversation with her, odds are I'm driving out those things inside my domain. Does she need to know that those classes as code exist? I don't think she does. I think she needs to know simply that the system completes this feature all the way through. Now, am I passing entities that we've named together called shopping carts, person, customer through that system? Sure. What's interesting, what's even more interesting than the way it works now is what if I could start typing that requirement and I already had defined shopping cart as a noun. And as I typed inside my feature file, given a new, and I hit big S, IntelliSense says shopping cart because that's part of my domain language. How interesting would that be? When I do this, then I get that. And I think that this is where we'll go. The next place we'll go is modeling the requirements this way so that we can extract the domain language from it. And vice versa, however you want to look at it. Anything else? Thank you all very much.